Good morning and good afternoon to our guests. Today we have our webinar on automated application security testing with GitHub Actions. Before we begin, just some quick housekeeping rules. We do want this to be an interactive webinar, so please make sure that you ask questions in the question box. We also have some great assets for you to download, so please take advantage of those. They're in the attachments tab. And we will be sending out the recording of this webinar after the event. And with that, let's get started. I'll introduce you our great speakers. We have Scott Gerlach, who is co-founder and CSO from Stackhawk, as well as Solomon Rubin, who is our wonderful software and security engineer at Fossa. And with that, I'll turn it over to Scott.
Awesome. Thank you so much. Welcome everybody to the awesome, amazing Stackhawk Fossa webinar. We're talking about application security testing today and how to automate that stuff, why it makes sense in GitHub Actions, and how to build a really robust security program in GitHub Actions and deliver quality software faster. And that's the whole point of building some of these tools. Today, we're talking about why automate application security testing, why you would want to do that, why you'd want to give that information to your devs earlier, that shift to developer-centric security, some of the types of application security testing. So there's a lot of acronyms out there in the world that are all mean something different, and they all do something different. So those are good to kind of understand. We'll walk through a little bit of that. We'll talk about Solomon will talk about example stuff from Fossa, which is really cool. And then I'll talk about example stuff from Stackhawk. And then we're going to tempt the demo gods on a live webinar and see what doesn't go wrong, watching through real-time scans, fixing some issues, triaging some issues, and then we'll go into Q&A. As Gabriella said, if you have questions during our presentation, please ask them in the questions panel. We'll try to do them as we're going. We'll try to catch them as we're going and make sure that everyone is kind of on the same page. I'm going to post the link. This repo is what we're using today. Let's see, display announcement. Yes, here we go. So now there is an announcement of the repository of code that we're using. We're using one of my favorite vulnerable applications because I wrote it. It's a very vulnerable Django project that's got some problems in it. And so we're going to work on kind of triaging some of those things and fixing a couple of them. We'll go through all that stuff. Step one, why should we be fixing security bugs and why should we be fixing them early? So everybody, I think, inherently knows that fixing security bugs late in the development cycle is really, really expensive. And there's this deep source IO chart that is really good. Actually, that link is a really good read. But the exponential cost for when you find bugs in applications, and these are all kinds of bugs, right? Application security bugs, functional bugs, UI bugs, all that stuff, exponentially more expensive to do, to fix those things when you get to production or post-release. And so those are some of the things that we're trying to help fix, right? Where this whole shift left movement is about pushing stuff back to that requirements, architecture, coding, integration, component testing, where your cost of finding and fixing these bugs is about 3x less than if you only find and fix them after you release. And so some of you may be asking, isn't this exactly what testing is for? So unit testing, functional tests, integration tests. This is exactly why you write all of those things as a developer and have your QA team or you check them. And so failing those tests before you commit that code, having those tests back you up in CI/CD is really the cheap way to ensure that you're putting out high quality software really fast. But what about those risks and defects that are not covered in your test case? So it's really hard to write what I like to call negative test case. Like we write positive test case. It should do this, and here's the test. It should do this, and here's the test. It's really hard to get really good coverage on the negative test cases. It shouldn't do this. It shouldn't do that. And that's exactly what these suite of tools are for, these application security tools, to help you reliably find security issues without writing those exhaustive tests for your application. Being able to test automatically as you're building software, as you're deploying software, and finding that issue, fixing it really quickly.
And the one other piece that I think is often overlooked is that, how do you know what's going on in your third-party code? I mean, there's so much stuff that we include from random places on the internet. You know, what's happening there? Are there vulnerabilities? Are there stuff that maybe shouldn't even be there? Like, you know, we've just seen a lot with dependency confusion lately. You know, what's happening in that code that we're not even testing for directly? You know, how do we figure out what's happening there? Tests often don't check for vulnerabilities or security issues or license issues within the third-party stuff that we're bringing in from the internet.
Yeah, totally. It's a great point, Solomon. When we write functional tests and unit tests, we usually we're covering the code that we write, right? We're hoping that people have covered their open source libraries in a similar fashion, but this can help, right? These set of tools that we're talking about here can help you get good coverage across code you include and code you write in your application. So the answer to the last question is obviously with security tools that are built for developers. And that's a really important distinction there, is tools that can help inform development teams and developers about mistakes that they may be introducing or making as they're building applications, as opposed to what is probably the traditional method of, I built a thing and now I've got to let the security team find all the problems, or worst case scenario, bug bounty programs find all the problems, or even worse, threat actors find all the problems and action upon them. But the really important part here is tools that work in the flow of development result in less back and forth in tickets. And so if you've ever experienced this, where the security team dumps a load of tickets into a backlog and goes, you should prioritize these when you have a chance, and they never get prioritized. And then when they do, it's really hard to go, I don't understand what this thing is. How do I recreate it? All those good things. But with these security tools built for developers, they scale more efficiently because we're putting those tests and the result information directly in the hands of the people that fix these issues. So avoiding that back and forth between security teams, that often there are some really good security teams out there that can fix issues, but security teams that often don't fix issues, and development teams that do, reducing that back and forth is super important here to be able to, again, quickly and efficiently build highly functional and quality code. So let's talk about some of the application security testing methods that are out there. These are sort of generalized, guess what? They're about what we do. Generalized testing methods that are out there today. They're static testing techniques. And those are focused on examining source code and looking at dependency libraries and lots of other written code type stuff. And the important distinction here is the program is never executed or interacted with directly. So there can sometimes be a lack of context of what's going on in the application, or how it's using data that is input by a user, or whether or not a library is exposed externally that you're using in a way that is vulnerable. So some of that is static testing, and dynamic testing is kind of the opposite. It's not looking at code necessarily, so sometimes it doesn't understand exactly how that code is getting built. But what it is doing, and is a little bit better at, is the context of what the application is doing. So understanding what's happening when you put bad inputs in, and how the application handles that or responds in a sane or insane, I don't know what that word is, fashion, whether it's supposed to or not. And the really important part is both are rooted in finding defects and are supplementary with their own strengths and shortcomings, as kind of talked about a little bit there. So both of these tools are really, really good at getting great coverage. There's a handful of other tools that are like IAST, which is runtime instrumentation, RASP, which is also runtime instrumentation, but can block, WAF, and a handful of other things. If you are starting on your application's security journey, I always recommend starting here. Solomon, what are your thoughts here?
I think these are a really good place to start. They're really easy to instrument, and it gives you a lot of information really quickly. It allows you to kind of surface some important information to the right people really quickly.
Would you say, Solomon, that this is the penultimate holy grail of application security? If you do these two things, no problem will ever exist in your application?
No, I think that's probably a dangerous statement, but I think it's a really good starting point to kind of get you in the right place to have a lot of information to help you fix a lot of the critical problems.
Yeah, I think
Would you agree?
I would totally agree with that. That's a loaded question, right?
Yeah, I like
obviously,
anything that's like, this is the ultimate thing, is especially with the context of security, is like, I don't want to say yes to that.
Yeah.
That's going to get me in trouble.
I always like to say the ultimate in application security, the most perfect app is one that is not running.
Yeah.
Like that's the only way it can ever be absolutely perfect. Is if
don't write
off. Yeah, that's right.
Right. Don't ever start.
That's right. So, obviously this is a journey. Application security is a journey. It's about taking care of those big, easy to find things first, and really increasing the cost of a threat actor to find stuff to action, as well as taking care of those big rocks that are super easy to find. So getting the easy to find stuff out of the way is super important. And most of the stuff that both of these tools find is really easy to find and easy to action.
Exactly. I agree.
Solomon, take us through it.
All right. Well, thank you, Scott. So let's start off this journey with some software composition analysis with Fossa. So what exactly is that? And to start, let's talk about, who Fossa is. So Fossa is a venture-backed company that has made it our mission to really de-risk the open source environment. There's a lot of stuff on this slide, a lot of numbers, a lot of companies, but what I really want this to kind of mean to you is that, we have identified a ton of licenses and code to kind of help de-risk your license, your license compliance stuff, as well as we've identified a ton of software vulnerabilities in code, like hundreds of thousands. And that's really cool. That's something that I'm really excited to have been a part of. And I want to talk about how we do that and what makes software composition analysis really kind of cool. So to start, we have to understand, how software composition really works. And the first piece of that is identification. Software composition analysis, analysis is not helpful if we don't identify anything. And that really starts with looking at your code, going through your dependencies and figuring out what's there. And that doesn't just mean, oops. What's going on? Okay, we're back. Sorry. Got some slide movement. So what that really means is we're not just looking at like what dependencies are directly in your package.json or gem file. I don't know Ruby, so I'm not actually sure what that looks like, but we're looking at your dependencies and your dependencies and your dependencies and dependencies to like the nth degree. So we're going all the way down what we call the deep dependencies to create a dependency graph or a dependency tree. And we take that and we upload that to our servers and we do a deeper analysis to see like what is actually in that code. We scan all that and we pull all that together and we cross-reference it with both our huge license database, and we'll curate more based on the stuff, the data you give us to say, all right, maybe we don't have this particular license, but now we do have it. And then we also cross-reference it with our vulnerability database, which we've been building for a number of years now. And it's something that we update daily. We have a research team. It's curated, it's built, it's something that I have personally been working on for a very long time. And we think that it's one of the best out there. And we think that this comes together to kind of build a particularly exhaustive and what we find to be a really noise-free compliance and vulnerability inventory, which is really important. It helps to service the information that's important directly to engineers. So that's step one. The next piece is policy, building a policy engine to help your organization figure out what's really important to you, what matters for your environment in terms of security, because what might matter in a healthcare environment isn't going to matter in a web environment or on a mobile phone or in a watch or something like that. So you want to be able to build policies to work for you, depending on what you're doing. So we have a really nice policy engine that allows you to do that, both for security and compliance. And I'll work through that. I'll talk through that a little bit more in later slides and through our demo. And the last piece of this is We're developer friendly. We're an engineering company built by engineers for engineers. We are here to make sure that when a lawyer says, hey, this license isn't cool, that it can go straight into the engineer's workflow to say, hey, like this library that you're including is going to be an issue, or hey, this library, it has a security issue and maybe we shouldn't be using it, or maybe we should upgrade it if there is an upgrade path to fix that. And that's what we want to do. That's what we're talking about today. How do we upgrade our code faster? How do we solve these problems faster to make it easier to solve these kinds of problems? Like that's the whole point here. So how do we do this? What does this actually look like day to day? So I want to run through a couple examples, and I want to run through even more as we get into our demo. I think that's going to be a lot more powerful, but I want to give you a sneak peek about of what these screens look like and how to actually kind of go through this. So the first step to all of this is integration. And integration works, all of this integration works across all of our products. That's security, which is, kind of one of our main focuses today. Our license compliance, which is important, but not maybe our main focus right now. And of course, container scanning, which we'll be looking at later, which is one of our newer products that's still in beta. So this all starts with, how do we get Fossa into your workflow? And I think this is particularly cool because it just kind of fits into what you already have. If you have existing CI, you can just use our Fossa CLI tool and it's going to work. And it's stupid easy. You just type in Fossa analyze or Fossa container analyze with the container name if you're using our container product. And then if you want some test results after doing an analysis, you just say Faucet Tests and you'll get that back. And it's easy. It's like that easy. You can run this on your local machine. You can run it in CI. It just kind of works. Or if you're using GitHub Actions as we are today, we have a really nice GitHub action that we've created, and it just wraps this tool in a nice, GitHub action wrapper that you can just use. Or if you want something a little bit simpler, you can just do a simple import in like a one-click import with GitHub or GitLab or whatever SCM you have to be using, and that will work for just about everything, which is really great. And like I said, this will work for basically everything, including container scanning. So that's like the first step. And once you've imported projects and you've done some scans and you have stuff in there, we start getting into the policies and issue resolution, and that's kind of the next step here. So when we have a security issue, we get screens like this.
Hey, Solomon, I got a question for you real quick.
Yeah, 100%.
Sorry, what operating systems does that container scanning support?
Oh, yeah, that's an awesome question. Thank you, Scott. So it runs on everything. I mean, maybe not a toaster, but if you can put Linux on a toaster, you can run Fossa. I just don't know why you would. So we run this on Windows and Linux and Mac, and that works for everything. Like I said, you really can run this on anything. As long as there's a CLI there, this should run.
Awesome.
Yeah.
Cool, thanks.
Like you said, we had talked about Windows testing the other day. This will work on Windows.
Yep, awesome.
So once you've got this running on your toaster and you've done a scan, you can basically get to this issue, issues page, where if you have a security issue, you're going to get all this information. And we try and make this as concise as possible because I think security issues can be kind of overwhelming. There's a lot of stuff there, and we want to make sure that you have as much information as you need without it being overwhelming. I find that like sometimes the MITRE pages, the CVE pages can be harsh, for lack of a better word. So we try and bring this down to be something a little bit easier to digest, where we still have that CVE information and the CWEs, which we can build some policies around. But we'll also give you, really concisely what the package is, what the affected versions are. And then on top of that, we'll expand what the CVSS scores actually are and those vectors of what's actually happening within this vulnerability. And we'll even tell you, hey, if you want to upgrade this to the next safest version, this is what it is. Now, I'm assuming, I haven't actually looked, but I'm assuming that the latest version for gRPC is actually probably a lot greater than 1.24.4. But this would be an easy upgrade path to say, hey, we can just upgrade to this and we'll be safe, which is really convenient. Similarly with license issues, it's really easy to kind of say, all right, hey, like there is a license issue here. Like this very clearly, Detroit has a GPL issue in it. We'll even highlight this is where that license issue is. Like, this is what a developer is going to see once they click on, in their CI or in their GitHub, a little commit check, which I'll show you a little bit later. They click on a little X that says, hey, there's an issue here. They're going to see this page and they're going to say, oh, there's a GPL issue here, or hey, there's a security issue in gRPC. I need to do something about this. Maybe I can resolve this because this is an action issue, but this one, I can see the license here, and this is very clearly an issue. So I want to do something about this. And maybe the thing is, I need to go talk to my lawyer because this is a library we need, and we need to figure out how we can use this safely. Or maybe it's something that we can just get rid of and figure out a different library for. But we kind of try and surface as much information as possible. What licenses are in this? Maybe there are more licenses than just this GPL issue, as we can see here. This is not a great example just because there's 2 GPL licenses in here, but we can see a total of 9 matches towards the bottom of the screen, as well as other direct dependencies. But we try and surface as much information as concisely as possible. So before I hand it off to Scott, I'm sorry, I have one more slide here.
Sorry, I had a question for you, Solomon. Sorry, I was on mute, trying to be nice, and then I started asking the question.
I love questions.
On that last screen, this is something I've always struggled with a little bit in my career and in my life. Maybe not my life. Is there a thing that Fossa does that says, hey, you're using a GPL library, and do you guys have a matrix of you could replace it with at this point, or is it something you're looking for in the future, or is that something that you can help advise companies with today, or something you're planning on doing?
In terms of like replacing it with library X, or
yeah, so like in this case, you've got this Detroit library, which is oddly named, but if someone runs into this Detroit library, you could go, maybe you could use the Flint, Michigan. Maybe not that. It's too soon. But is there a thing that you guys have roadmapped or exists today that says you're using Detroit, you could also use this other thing that's very similar?
So that's not something we currently have, purely because it's really hard to find parallels between libraries like that, and just the amount of libraries that exist in the world is just so massive that building that kind of matrix is difficult, to say the least. I think one of the first slides I saw, showed that we have identified something like 230 million licenses. It's just this massive number. Sure. I think what we try and do is surface like, hey, this is an issue, and we kind of let the user decide how they want to handle it, because it's very possible that the way that this is being distributed might not be an issue, or that this library is so critical in how it's being used that it doesn't matter. But we have so many libraries and so many different languages in our database that creating that kind of matrix
no, I totally hear you.
Likely wouldn't be
the complexity of how you're using it, where you're using it, what you're using it for is very intricate, and it's really kind of up to the engineering team that's deployed it or included it for whatever reason to go, oh, we actually don't need that, or it does this. Now I can go searching for this particular function, versus what happens when a security team gets this stuff and goes, hey, rip this out.
Yeah. Now, what we do have is a lot of our policies are underwritten by the open source lawyer, Heather Meeker. I think I'm pronouncing that right. So a lot of our kind of policies around this are like very well written. And, we're also kind of behind the somewhat controversial, oh no, why am I forgetting this? What an awful moment to forget this, the common clause license. So, we do have a lot of kind of access to these policies and the open source licensing world. We're also behind TLDR legal, so this is kind of our like bread and butter.
Cool.
So this is a big part of what we do. Definitely, it's a great question. Thank you for asking.
Yeah, thanks.
So lastly, before we kind of recap everything, this is our policy engine, which I think is really underpins everything we do. And I don't want to talk too much about our compliance stuff because today we're really here about security. But with compliance, very briefly, we do have an ability to say, hey, you can either deny, flag for review, or approve. With something like GPL, it's a little bit more dangerous to just include stuff because you might end up having to disclose all of your source code. But for something like EPL, if you're not modifying it, you're kind of fine to include it. So you can flag that for review. Where with something with MIT, it's MIT. You can kind of do whatever you want. So you can always approve that, and then you can have a default action. With security, we have a different style of policy where you can say, if you don't care about a severity less than X, be it medium or 5, depending on if you want to do the severity, English word versus the score, we can filter that down to, continually reduce your noise. But on top of that, if you, let's say, work in an environment where particular common weakness enumerations are really important to your environment, like let's say on the example on the screen, relative path 23, if you always want to get alerted on that, no matter if the CVSS score is a 1 or a 10, you can add that to our deny rule list, and that's always going to alert. Conversely, if you want to never hear from CWE 32, you can also have that always silenced. So we have a pretty powerful policy engine that allows you to say, hey, based on my environment, this is what's important to me. And this is how I want to kind of build out my security policies. So just to recap before I hand it over to Scott, Fossa is really easy to integrate. The base is just Fossa analyze. That simple, just kind of works. And it fits into your workflow, just using your CI and your SCM, which is great. And we really work hard to make sure that the important information is surfaced to you via these intuitive UIs. And like I just went over, we have these robust policy engines to make sure that the policies are built to really give your team and your organization the most context to work for you. And then lastly, we have this comprehensive vulnerability database that's underpinned by our research team and updated daily. And it's a huge part of what makes our security product so good. And with that, Scott, it's all you.
Awesome. Thanks, Solomon. Super good information. Let's talk a little bit about Stackhawk and dynamic application security testing, otherwise known as Dast. If many developers out there may never have heard of this term. I know a lot of them are familiar with SCA. Dast is maybe a newer one, newisher one. And dynamic application security testing is, I think, super important because of what it does and how it does it. So let's talk a little bit about some of those things. So first of all, why is Dast a good tool and important? The start of this is there's no language dependency with Dast because it's testing the running application. However you compile and run your application, it doesn't care what language you wrote that in. So if you're using something cool like Rust or handlebars or whatever language it is, sometimes you don't have good static code analysis support for those in a lot of systems. And that's why Dast is great. And this is why I use Dast, have used Dast a lot in my career, is because it just tests the running application. So it knows how to do inputs and outputs based on how that application is set up. And we'll just throw negative, bad inputs into stuff and see what happens. So that's really good. That's also how the context of that application. So it understands if I put stuff in this form or I submit stuff to this REST API or GraphQL API, and stuff that comes back out of that based on what the application or program did, either says that's a problem or probably a problem or not. And that's that context running thing. And then I like to think that Dast actually has lower false positive rates because of what it's doing there. So most of the time, when a Dast says, I'm going to send this cross-site scripting input into an application, if it comes back and it detects it, it's probably a legit cross-site scripting issue. And that's some problem with some of the SAST tools out there, is it doesn't really understand how the application is handling an input from a user or how it's handling an output from a user and what happens in between sometimes. So that's why I really like Dast and why I think it's a really good part of an application security program or application security testing regimen as you're building stuff. And then Stackhawk allows you to find and triage and fix those security bugs in your application quickly. So this is, we're going to see some of this stuff in our demo in a little bit, but being able to quickly get a summary of what am I looking for, where does it exist, and then being able to go, hey, I understand how to recreate this problem, how to make a request that looks like this exact issue, so I can get my code into debug mode and start stepping through to figure out where I've missed something. And then the other thing that's important here is, and we're going to see this a little bit as well, some of these triage states. So I can say, this stuff is really important. I'm going to make a ticket out of it. We're going to fix it later. I'm going to keep finding it until I fix it, but it's going to stop trying to bring my attention to this issue that I've triaged already. So that's super important to kind of get out of your way. Triage once or fix once, get out of your way and keep doing the job that you got to do, which is building software. Again, how a Dast scanner works is it makes HTTP requests. So Stackhawk is very much an HTTP application tool. And it finds things like SQL injection and OS injection, cross-site scripting, but it also finds things that other static code analysis tools can't see, like cookie safety. How are you setting flags in your cookies? How are you setting content security problems or content security policies in the application itself? Some of those security headers, cookie safety, lots of other really good stuff, X-frame options, things that are kind of important to an application security context that static code analysis can't find. Today, we are talking very importantly about GitHub Actions. And here's how easy GitHub Actions is. We're going to look at both of these. Both Fossa and Stackhawk have official GitHub Action published. So it's very, very easy to use those things. And what I didn't do, yeah, I did it. Okay, this is right. It's very easy to get started in GitHub Actions. And why we're talking about GitHub Actions is it's super accessible. If you have a demo project, you can spin this up, both of these tools in your demo project and see how they work, and then start moving that into a corporate project or a work project. Can you run these tools in other platforms? Absolutely. So GitLab, the list, Jenkins, the list is really long on where you can run these things. If you can think of a CI system that you're building in, and I can list off a ton of them here, is Atlassian Bamboo, AWS Code Services, Azure Pipelines, Bitbucket, BuildKite, Circle CI, Concourse, any of those things, these tools all work there. But I think GitHub is actually a really good place to kind of test this, see how it works, get good feedback, and then move on from there because they all kind of work the same.
So there's a quick audience question that I just want to surface is what's the difference between like a normal CI and GitHub Actions? How does like this differ from just running this in CI?
I think it's largely the same. Depending on how you're building software, I might not be understanding the question exactly right, but I think it's very much similar to how other CI works, right? You can trigger it on code commit, on PR or MR. You can trigger it in a specific fashion. You could probably even schedule it if you really wanted to.
Probably.
But all of those things are kind of the same across all these CI services. I just think I really like GitHub Actions a ton. And I think it's super easy to understand how that workflow happens in GitHub Actions. And we'll dive into that a little bit more in the demo.
Yeah, I really see this as just like a really nice wrapper for these tools. Like it just kind of, someone builds it for you and then you just stick it in and you're like, all right, it works.
Yeah, totally. Good question. Thank you. So I'm going to skip this screen because it's kind of, we're just going to talk about it in the demo. So this is for later if you want to look at this. This is just kind of a summary of what scan results look like when you run them on a laptop or in CI. We're going to see that as well. And this is the triage interface for Stackhawk. We're also going to look at this a little bit, but the important thing here is to be able to see the request and the response that the application gave. So you can see where that malicious input went in, how it came back out. And then I'm going to show you what happens when you click that sweet little validate button there in just a little bit. Quick recap of Stackhawk. It's super easy to get started. It's a few lines of YAML configuration. We're going to look at that a little bit as well. Works in almost every CI system. You can definitely wire these checks up on every PR or on code commit, however you'd like to make that work. Multiple ways to address an issue. So you can go, I'm going to fix this right now. You don't have to do anything except for write code and recommit it. I'd like to make a ticket out of it. It's important that we fix this, but we're going to do it later. I don't think this is super important, so I'm going to risk accept it or false positive. Very few of those false positive things show up, but they do happen. So there's a way to do that. The cool thing is the scanner remembers when you do that triage action. So it remembers when you say, I made a ticket out of this, and it stops trying to bring your attention to these things. And we can actually break builds based on that, which is something that we're going to look at as well. Tries to get out of your way. If there's no new issues, everything works as it's supposed to. So that's always good. And lastly, it helps you build confidence that you're not making security mistakes in the code that you write. And then with the Fossa addition as well, the code that you include. Okay, here we go. You ready for this, Solomon?
Awesome. I'm so ready.
Let's see if we can not break the internet today.
Let's do it.
Alrighty. I'm going to go ahead and share my screen here. We'll look at some of the stuff we're working with. Solomon, let's start with the Fossa stuff if you want to.
Sure.
Or if you want to share your screen and drive on your side, that's fine as well.
Yeah, why don't I drive real quick,
Yeah,
and
cool.
then let me just take this back from you. Oops, actually, if you want to stop sharing for a second, then I can take it back over.
You got it. Oh, look at this.
Oops, my webcam's off. That's not
Hey.
fair. There we go. All right. Let's take this again. All right. So let's just walk through this repo real quick to kind of go through the workflow and start from there. So this is that repo that Scott is so excited about with all these vulnerabilities. We can see that there's tons of tests failing. The license scan is failing. The security scan is failing. Everything's failing. This is just nasty. Let's take a look at that workflow so we can kind of see what's going on. So we've got this Github workflow named test with a couple of jobs. So this first one here is really just about running the standard Python test. So this is these unit and integration tests that we were talking about earlier, really good, but not going to service everything. Following that, we've got the Faucet tests, and these are dead simple to run. Similar to the Stackhawk actions, it's really just a matter of we clone the repo, and with an API key, we just run a vulnerability, run a vulnerability scan, just like that. And along with that, we also do a license scan, which is super easy. The other thing we do here is we build a Docker image. Because we're doing container scanning, I want to make sure that we have a Docker image ready to go. So we build that image, and then we run it through the container scanning portion. And the way we do that is really simple. We just say, add this keyword container. The container name happens to be app due to how this image is built. And that's it. It's done. So when we actually go and do that, we'll let Scott go through this portion a little bit. But once we go through that, we can go over to actions, and we can go to this beautiful failing test. And we can see the Python tests, which are looking good, even though we know they're not. And we can see the Faucet tests. Now, notice that the Faucet tests are passing, and that's because we're not adding the dash test or the test keyword. And so what happens here when we actually run this is we're doing the analysis. We can see we're analyzing pipenv, which is what we're using for the pip environment rather than requirements. We're using pipenv and setup tools, because there's also a setup.py file in there. So it's analyzing those two pieces, and then it gives us this report, which I've already got set up here. So I will move over to that in a second. And then the other piece is, of course, this building a Docker image and running the container scan. So we have a really similar kind of view for using project name app. We've got the revision, which is just the the tag of this Docker, and then again, the report. So we can look at both of those. So when we jump into Fossa, this is what we get. We see the Fossa UI, and we have this main dashboard. We've got a couple of issues that we can look at, a flat dependency, and we can start to say, all right, what's going on? Actually, before we do that, let's take a look at one other thing. If I actually go into this is what I really want to show. So this is failing too, and this is what I think is really important. While that test isn't failing, we are showing that the license compliance and the security analysis is. So if I go into pull requests and close, it's a sneak peek of what we're doing a little bit later, and I say, I want to add this Fossa badge, I can actually see here that this wasn't passing when I tried to merge. So this was a bad merge by all engineering standards, because these tests were not technically passing. So this is one of those ways that we are surfacing this kind of license and security information immediately to the developers. Say, hey, something is wrong with this commit, or something is wrong with this PR. Maybe don't merge that, even though I did. So when we click on that, it'll bring us back to here. I think it'll actually bring us directly to an issue page. So let's take a look at that flagged license real quick, just to see what's going on, because I actually know that this is a false positive, and this is something that we can really quickly deal with. So when we look at this, we're surfacing here the license in Flake 8, which is one of the dependencies we have. So it actually says here that we're using this particular attribute because it can cause issues with GPL license, but it's not actually GPL license. We're just flagging this, under extreme caution. So I can actually say, this isn't actually an issue. This is not actually GPL, and I can just resolve this really easily. And then suddenly there's no longer, if I rescan, there's no longer any license issues. So we just took care of one of those issues really easily without having to do anything. All I had to do was look at that license, read it really quickly, and we're done. And from there, I can continue down to look at the security issues, and we can start to see what's going on. And we can see, all right, we found this version in this project. It's version 3.0.10. The affected versions are, yep, it's definitely within the range here of 3.0 to 3.0.12. If there were deep dependencies in this project, unfortunately, because Python's a little bit weird in how it pulls in dependencies, this is not technically a deep dependency, but it would show me how I'm actually introducing this dependency in. So if something like Node is like really, good at having like a ridiculously long introduction path, it would be like, oh, it's coming in from these 10 different packages. I could do something with that. So I can see that this is vulnerable. This is something I definitely want to deal with. I could potentially create a ticket in Jira. I don't have Jira set up, so I'm not going to. I can also, that's a rough README. I'm going to skip past that noise. I can also look at this one. I know that this is vulnerable. We are introducing one version behind this, so we can fix this as well in a little bit. So yeah, and the other thing that I want to quickly surface here is before I pass this back to Scott to kind of share some of the Stackhawk items, is our container scanning. So we have a lot of vulnerabilities here, and this is because Linux is just super vulnerable. And a lot of these exist within our base image. So a lot of this just comes to upgrading the base image or kind of just dealing with it, or using something that's not vulnerable at its base. This is a Ubuntu base, I believe. But I can kind of dig into this, and we can see that within this particular image, we have just tons of stuff. And one of the things that I know is in here is like Maria. What is going on with this UI? Man, we really are tempting the demo gods today, aren't we?
We definitely did not break the internet.
No, man. All right, a UI update happened overnight. Okay, well, we're gonna skip past that and pretend this looks perfect because it normally does. I promise. We can see quite a few of these Linux libraries. Some of these are familiar, some of these are not, and a lot of that's because these are coming in from the base image. Now, at the moment, this is in beta, like I said, so we don't necessarily surface the information of what's base image and what's not, but that's something that's coming in the next couple of weeks to months. It's it's coming soon. And we can also see all the licenses as well as, hey, there's a vulnerability in apt, or there's a vulnerability in bash, which is likely not the vulnerability I thought it was. But so we can see a lot of that. I'm not going to go through these and fix them just because there's so many and most of these don't have fixes. But I wanted to kind of go over this because this is one of our newer features and something that I'm personally really excited about. And I know that the people who worked on it are also really excited about. Yeah, Scott, do you want to go through fixing some of these issues with that PR real quick, or do you want to pass it off to you? What are you thinking?
Let me walk through the Stackhawk stuff, and then we'll triage some of the issues that we're finding with Stackhawk, and then we can kick off that PR and see what happens with the build.
Sounds good. All right, all you.
All right, here we go. This little split screen thing is weird.
It's very weird. It's like a
all right,
phone
here
camera.
we are. So we're in the same dark mode this time. We're in the same repo here. We're talking about the same project. A little setup. This is a Django project. You probably understood that from the dependency thing that Solomon was showing. But it's a Django project. It's the base Django polls project. So I just built the tutorial Django project. It's got some problems in it, but that's what it is, and it's all containerized. So this is what's happening when we're building this thing. So we just talked about that container. There's obviously a Docker file that builds the Django thing, but it's got some dependencies as well, and they're in the Docker Compose, and they're Postgres for the back end and the app itself. So what we did to define how to scan this thing with Stackhawk is set up a Stackhawk YAML. We'll look at that right now. And basically that's super important. Here's really all you need to be able to do that. So that application ID comes from Solomon's Stackhawk account. It's his application ID for this vulnerable Fossa Stackhawk demo. And then we kind of define an environment by default, kind of development. That's where I do it on my work on it on my laptop, and that's where you can find that running application on localhost 8020. There's a couple new things that are in this configuration file that are really awesome. Auto policy true, and auto input vector true. That both of those things tell Stackhawk, hey, I want you to optimize this scan for what you're scanning. So in this case, it's a server-side HTML application. So it will pick the appropriate policy to be able to understand how to input forms the right way, how to input clicks and URLs and all that good stuff. When you transition or use Stackhawk to test a REST API or a GraphQL API, it understands that, hey, you know what? There's actually probably things in the URL for REST API that need to be input. And all the input data should be JSON payloads. And in GraphQL, it understands, hey, all that stuff needs to go into input variables in JSON inputs as well. So, and then it undoes some of the HTML content scanning that the scanner will do as well. Excuse me. So really, really good at optimizing how to scan an application. And then the other thing that we did way down here is set this failure threshold. So basically what we told the Stackhawk scanner to do was, if you find an untriaged high issue, I want you to exit non-zero and break my build. Doesn't do this by default. You actually have to set that. But this is a really good way for us to go, when you find something, tell me about it. So we're going to look at what this last scan did. Then we're going to triage some of the stuff in the Stackhawk platform. I need a drink of water and to cough again, so hang on one second.
Right after you do that, can you bump up your font just a little bit?
Yes, I certainly can.
Thank you.
Look at this. Boom.
Perfect.
Thank you for
beautiful. 100%.
And then I missed the mute button. Sorry for coughing in everyone's ears. So we're going to look at this Stackhawk scan, which actually failed. So we can see that we set up these containers. Auto scroll for the win. We built these Django containers themselves. Then we ran this Hawk scan. One thing I'm super embarrassed about is I didn't actually use the Stackhawk GitHub action in this thing. I'll fix that later today so you can pull an example that is better. But what happens there is it kind of fires up and it goes, hey, I know that I'm using the Stackhawk Scanner. We actually use this override file, so we support YAML overrides to change where to find the name of the running host. I'll show you that in just a second. So that actually changed it from localhost to this vuln Django host name, so that the application can find it. And the other thing it did was change the environment name. So we're changing this environment name to GitHub, so we know where we're scanning and we can bucket these things a little bit differently. But then what it does is it fires up and it crawls the web page. In this particular case, in REST API and GraphQL instances, it reads in the Open API spec or the GraphQL introspection endpoint to be able to go, I understand exactly what this application is. I'm just going to test away. And then it started testing, which is all this fun stuff. And then here's the output of that stuff. So we can see we've got some SQL injection stuff, some cross-site scripting things, and those are all high. And so that's why our build broke down here. But the other thing that comes in is, here's this link to this scan on the Stackhawk platform. So you should just be able to click into that. I've already got this set up so that we can just go right into the same scan results. And now I've got some information about what's going on here. I've got those cross-site scripting and SQL injection high issues that it found. I've also got what plugins ran during that scan. That's all real time, so you can watch this as a pretty little chart that runs, that fills out while it's running. Some of these skipped things are because of that auto policy thing. And the other thing that we did was made this really cool technology flag thing. So inside the application here, when I can click on this button, I also get UI errors. Thanks, Solomon. Not that it's your fault.
That's what I'm here for.
Yeah. Oh, awesome. So down here, we've got this technology flag section. So we can tell Stackhawk how we've built this application. So we're using PostgreSQL. We were using SQLite in this at one point. Python, Linux, Git, Apache. So it'll skip a bunch of tests. And you can see that in that scan result that we were looking at there under this plugin summary. So these are all skipped specifically because we're not using them. So that makes the scans faster, more accurate, leads to less false positives. So auto policy, technology flags, auto input vectors all help the scan go faster, find the right things, and be less false positive. So let's dig into this issue here. We're going to look at this cross-site scripting, then we'll look at that SQL injection. Once we click into those issues, we can see what path those things exist on, and we can also see the evidence of what got injected in the request. And here it is, URL encoded. So that's kind of cool. As well as the response. Here's where that came back out of the application. So this is getting you into, how do I recreate this request? How is it presenting itself? Where is this problem? So I can get into the code and start fixing this really easily. But the other cool thing is, as promised, here's that cool validate button. Shows you a curl command that recreates this request exactly how the scanner did it. So you can also post this curl request back to your local running application. There's some stuff to tweak in here depending on the host name and a couple other things. But getting back to how do I make this request do exactly what the scanner did so I can fix it? Super important. We're gonna mark this guy as important to fix, but we're gonna fix it later. So let's push it to a Jira ticket, shall we? I've got a Jira integration set up for my development organization. I'm just going to push this out there and go create an issue. Boom. My issue has been created in Jira. I can click this little link and see that issue. And importantly, in that issue, there's a link back to that screen we were just looking at. So if this spends some time in the backlog and doesn't get prioritized for a while, when it finally does, an engineer can go click this link, get right back to here to be able to quickly triage that information and fix that problem. We'll do that same thing for this SQL injection thing. So now you can see that this is no longer new. Now it's assigned to a ticket. We're going to do the same thing with the SQL injection stuff. So once again, you can see the request that made the SQL injection work and the response that came back out of it. And also a UI error. Sweet. It's good day for demos.
It really is. Happy Thursday.
We're also going to put these in a Jira ticket. So that's just assigning it to a ticket. Whether you have Jira Cloud or not, if you don't, you can make a comment in this and make a link to your ticketing system. So that could be GitHub Actions or GitHub Issues, some other ticketing system. I've got that Jira set up so I can do the same thing. So once again, those two things are set. So now they are both in a triaged state in my Stackhawk console. So the next time I run a scan, it will continue to find these things until I fix them, but it's going to stop trying to bring my attention to it. And this should no longer break the build because they've been triaged. So that's really good information. And I think that's what we wanted to see in here, right? Did I miss anything, Solomon?
I don't think so.
One thing
Everything
I wanted
below high doesn't matter.
To me, everything below high does not matter. Like I want to know about those things. I just don't want to break
Exactly. I agree.
I did want to show you this Stackhawk GitHub, which is just resetting the environment name to GitHub, resetting the host, where to find the running application, and the rest of the stuff that's in this Stackhawk YAML takes priority if it's not reset. Awesome.
Love it.
Solomon, coming back to you to fix some of these issues in SCA, and then we'll see what happens when we rebuild projects.
Cool. So let's do that real quick, and then I want to make sure that we have a little bit of time for questions. So we're back here. So I've already actually staged this pull request with some issues. Quietly did that while Scott was talking. Just kidding. Last night did that at like 2 a.m. So like I said before, we had these issues in URL-lib3 and Django, which was coming from our vulnerability database, cross-referenced with the dependency graph. And we end up with this. We have an updated pip file where we're updating URL-lib3 to version 1.25.9 and then Django to 3.0.12, which are the most up-to-date. Well, they're not the most up-to-date version, but they are not vulnerable versions. They're the next safest version is what we call it. And when we go through these checks again, we're actually going to see, now this was done last night, but if we actually scan this again, we're going to see now that there are no issues because if we rescan this now, see all the issues are gone. We fixed that licensing issue just a couple minutes ago. And because those security issues are now fixed in this PR, it's gone. So this is actually referencing this particular commit, which is great. So now this may not update until we push again because GitHub is a little bit more static than we might like it to, but we can squash and merge this. And when that runs its scans, it will update. So I'm just going to go ahead and do that quickly. Can bump that, and what we'll see as we kind of move back here into our actions is everything will be running. This is going to take a second, but everything will be running, and as we come back to it, all of these, the license scan will now be passing, which we already see, as well as the tests will start to pass. And I think that will work for Stackhawk as well. Is that correct?
It should work for Stackhawk. We triaged all those issues, so our threshold is set to break on new issues of a high priority. We triaged all those issues, so we'll see what happens. It should find them again, but it shouldn't break the build this time.
Well, while that runs, we can go. So what am I doing here? That's not what I want either. This is what I want. So yeah, we can come here and we can see that this is all set. And again, there are no issues found within our dependency. So everything is nice and green, which is exactly what we want. As well as in Stackhawk, we have assigned and triaged, like Scott was showing earlier. This is now my org, which is what the project's actually attached to. So we should be good once those run. At this point, I'm just trying to fill time as this actually runs through the tests. So this is probably a great moment to take some questions.
This is a good spot for questions. Anybody out there watching have any questions about what we're doing? Like, what the heck are you guys even talking about? Or what are you guys doing? Why is this? Why did you set it up in Docker? Obviously, you can do this in not Docker and push stuff to staging environments. Do the same license checks, the same Stackhawk checks. It's just a different host name. There's lots of ways to make this stuff work and work for you. And kind of get out of the way, questions out there from the audience, or I've got some, we might have some other cooked up questions in the back pocket here. Love to hear from the audience though. Come on, give us questions. Come on, give us questions. Nobody. I got a question. Solomon, what's your preferred coffee to start off the morning? What kind of blend?
Oh no, I'm embarrassed. I like espresso, and I'm lazy. So this combination has led me to be an espresso person, which I'm deeply ashamed about. Deeply ashamed of it. But on the other hand, I'm Israeli, and Israel is just owned by Nestle, so I guess it's not that bad. I have mixed opinions. What about you?
I also own an espresso, but I recently bought
I feel
a little
better.
little espresso machine, like a Italian espresso machine. So kind of the morning routine is part of getting espresso ready to go and either screwing it up or making delicious coffee.
Is it one of the like hand press ones where you have to like control the pressure yourself, or does it do it for you?
No, it's hand press. I got all kinds of great tools for making espresso.
That's phenomenal.
There was a question. There was a question sitting out there about the Stackhawk Scanner. If we used our own built our own scanner, or leveraged another tool. So we actually built our platform on top of the Z attack proxy. So Zap, which is an open source project that is widely used across the world, super well maintained, really good interaction with that open source community. Zap is a really, really good Dast scanner, does a great job. And we actually hired the founder of Zap, Simon Bennett, to work at Stackhawk, and that's what he does full time now. So he works at Stackhawk and works on Zap full time to help make not only the Stackhawk project really good, but get the feedback from Stackhawk users to improve Zap as well for the open source community. So really good partnership and integration with that open source scanning tool.
That's awesome. That's part of OWASP, right?
It is an OWASP project, yes.
Brilliant. That's really cool. One other question I see here is, does container scanning require like a secondary tool outside of the Fossa tool chain? And the question, the answer is no. It integrates directly into our version 2 of the Fossa CLI, which is really nice. We're trying to really consolidate all of our tools into one really easy to use command, so it can just you just use the one command and it kind of works for everything. So all of our new products are kind of integrated into that, which is really nice. So I think we talked about this a little bit before, but it's just like, you do Fossa analyze or Fossa container analyze. And again, it's all wrapped into the GitHub action. So in some cases, you may not even need to worry about that. But under the hood, it's all the same thing, which is really nice. And the container scanning product, loops into our vulnerability database that contains vulnerabilities for both, your normal, I'll call them language projects, like, Python, JavaScript, Java, Ruby, Haskell, what have you, as well as Linux stuff. I think we have something like 300,000 vulnerabilities now, maybe more.
That's awesome. Good. It's a good question. Any other questions from our audience out there? I see that a bunch of our things are starting to finish, so our Fossa check looks like it's all green.
Fossa is beautiful, although this green is kind of a false flag. I think it's the other green over on this side that we want to care about, and these two are green, which is great. One more green check that we are waiting for.
Hey, it turns out, Solomon, if you flip over to that Stackhawk screen,
yeah. And
then go back to the scans tab up at the top. You should see that running scan there, up at way at the top. And then there's all the plugins that are going actively, so you can see what's being tested and when, which is
really cool.
Yeah, so you can see how many times
what's in progress.
Yep, how many times it's iterating on a test, how many different versions of an input it's throwing into the application, where it is in that project or in that test suite. So you can kind of get a feel for how long it's been running and what it's doing. And if it gets stuck, oh, look at that, whap, went really fast. But we should
Yeah,
also be pulling back live results. So if you go back to the top of this screen and go to findings, you'll see these findings are starting to show up as we're scanning. So even if the scan fails, it will still throw out the findings that we found.
And there's no new ones here, which is
That's right.
great, because there shouldn't be. But B, like you said, it's not alerting.
That's right. So it looks like our scan is all done.
I think you're right. Look at that.
It's still. Oh boy, what happened there?
Oh boy.
Oh boy.
Tempting the demo gods again.
Well,
I'm going to say this is a home run anyways, because there was technically no issues there.
That's right.
Unrelated error.
Yeah, you can actually, if you go into
looking good to me.
GitHub action result there, I'll have to dig into why that failed. But if you scroll up to where those high issues were, so they should be at the top of this summary page right there, you can see that those issues are assigned now, right? So that issue is assigned, and the SQL injection issues are assigned. So again, it remembered what state we put that in the platform, and it shouldn't have bailed out and errored like this. Guess what I get to go do later today?
Fix it. Engineer's favorite job.
Engineer's favorite job. Awesome. I don't see any other questions from the audience. Is that like Gabriella just jumped in, maybe?
I put the slides up. That was me.
Okay, cool.
Figured we have 2 more slides left just to do a quick recap and our contact info. So
hit it.
Yeah. So I think the big recap here is, adding security testing is great. It's, it's just like unit testing and integration testing, but it gives you so much more information, and it's going to cover things that unit tests just can't. Stuff in your third party and stuff that, is kind of outside of the realm of unit and integration testing. And it's simple. It's really simple. It'll improve what's happening. It'll improve your security confidence, and that's important. And it's a great place to start if you haven't already started your security journey. This is kind of the starting point. It's going to give you really simple information that is really, really powerful. And CI keeps you honest. If you're already using it, you know that. If you're not, it's a great place to start to kind of build out your testing suite. And this is a great place to add on to that. These are all building blocks, and as you build onto your normal CI with unit tests, you also build onto your security testing. And this should really be a part of your normal workflow. And you just build onto your workflow as you go. And that's kind of the repetitious thing here. You just continually add more as your organization grows and changes. And this is kind of the first building block. So there's actually one more question that just popped up.
Ooh.
I think that might be a you question, Scott.
Yeah,
what's the difference
of behavior when selecting data types or risk levels? And that's something you can select in the platform. Today, that doesn't do anything, but it's going to help us inform giving advice to customers on what you should be fixing, or how you should be thinking about the risk or the data that your application is handling, and therefore what you should probably be prioritizing in that high, medium, low section. So you can think of that. I always think of that as this is the stuff that's above the line, so you should be worried about this and fixing it. And this is the stuff that's below the line, because that's always a hard thing for developers to kind of grasp, is how important is this stuff to this application, and these findings, how important are they to the application? Should I fix them? So that's a thing that we've got planned for the future. And then I see also another technology flags thing. We talked about that a little bit, where technology flags helps tune the scanner to be able to know what to test for. So instead of guessing about all the technology you've used to build an application, telling the scanner exactly what you're using helps it be more efficient, faster, and more accurate.
Awesome. Well, thank you so much, everyone, for joining. Sorry, we're about 10 minutes over. Hopefully the 10 minutes were worth it. Of course, you can reach out to either of us if you have more questions. You can also grab free accounts and try both Stackhawk and Fossa out. at fossa.com or auth.stackhawk.com. And you can also email our sales divisions to kind of get that conversation started if you have larger accounts. And both of our personal contact info is located right here on the slide, and these slides will be available. So if you have questions, if you want to connect with us, whatever, we're available. We want to talk. So thank you so much again. Any final words, Scott?
Yeah, totally. First of all, Solomon, thank you for setting up our demo project. I know you put a lot of effort into this.
No problem.
Only Django is my favorite thing to test with. But thank you so much to the Fossa team for collaborating with us on this webinar. I think these are great tools, help build a really robust application security program. And they, most importantly, inform developers on what things they can action and fix in fixing security errors or problems or bugs or whatever you want to call them to help build that high quality software. So super fun today. Thanks to all the people that joined and are watching out there. I know you're out there, even though you're not asking very many questions. But thank you for everyone bearing with us even though we ran over 11 minutes.
Definitely. Thank you. Take care.